Assalamualaikum and a very good day to Dr. Muhammad Zamir bin Othman and Dr.Tengku Syafazilla binti Tengku Saharuddin. My name is Fatimah Azzahra binti Saupi. My matric number is 1170870 and my supervisor is Dr. Nur Atika binti Nasir. Today, I will be presenting my review paper on title of A Review on Activation Methods for Activated Carbon and its Application in Dye Removal. Basically, there are five main components in this presentation. The first one is introduction, followed by methodology. The third one is body of content, and then conclusions. Lastly, references. For introduction, dye is a colored material that contains chromophore which produce color to dye. Some of the irresponsible manufacturers discharge this dye stuff in water reservoir. It causes dramatic pollution in aquatic life and become harmful to the inhabitants. One interesting alternative that has been used in order to treat this problem is by using activated carbon, which is a carbonaceous material. It has well-developed porosity, large surface area, and high adsorptive capacity. Activated carbon does the adsorption process, which is a collision of molecules at the surface of activated carbon, and the molecules losing their energy by transversing dynamic pathway to equilibrium, which called physisorption and chemisorption. They are responsible for chemical bonding and non-bonding interactions. Adsorption properties depend on some factors, which are precursors, activation method, and thermal purification. A key factor in preparation of activated carbon is the activation step, which has two pathways, physical activation and chemical activation. Selection of activator in chemical activation is a priority in producing the best activated carbon because it will affect the absorption properties. The next one is methodology. This is the method in preparation of activated carbon. Firstly, determination of physio and biochemical properties, and then it will undergo preparation and pretreatment. After that, activation of precursor, either by physical activation or chemical activation. And then finally, the activated carbon that being produced is used for the application of natural organic material removal. Now let's move on to body of content, where I will explain briefly on activation methods, activators, and application in dye removal. Preparation of activated carbon are mainly involved in two steps, which are carbonization or pyrolysis and activation. Carbonization is a process that produces elementary stable structure with partially developed porosity, while activation is a step to enlarge the pores and produce greater surface area. Typically, activation for activated carbon are commonly synthesized by two processes, which are physical and chemical activation. Physical activation comprises dual stages in reactor. The first one is conversion pyrolyzed raw material into biochar that has undeveloped pore structure with steady flow of inert gas. The second one is activation of biochar with activating gases such as carbon dioxide, oxygen, or steam. Excessive carbonization temperature is above than 1200 degrees Celsius might lead to the low yield of carbon and damage pore structure. Physical activation has its advantages, which is it is an inexpensive method and environmental friendly. While chemical activation can be conducted in two steps, single step is the common method where precursor mix directly with the activating agent, which called impregnation. Then, the impregnated precursor carbonized or activated at high temperature to produce biomass-based activated carbon. By contrast, the two steps involve precarbonization in order to produce char, followed by chemical activation process of impregnated biochar to produce biochar-based activated carbon. Chemical activation method can be accomplished by infusing, mixing, and permeation of dehydrating chemical that are able to induce and alter the composition of pyrolysis. These activating agents deeply penetrate into internal surface of activated carbon, contributing to development of smaller pores, thereby increase surface area. Normally, chemical activation requires low activation temperature with shorter time than physical activation. Therefore, it results in higher yield of activated carbon obtained than physical activation. There are three main classifications for activating agent, which are acid activation, strong base activation, and neutral activation. Based on numerous studies, phosphoric acid is the most widely used activating agent among others due to its property of non-polluting material compared to zinc chloride and easy to eliminate via water leaching, where phosphoric acid being recycled for other application. The recycled acid is very useful in base treatment process where neutralizing the solution to produce silica. Some studies focus on effect of impregnation concentration and soaking temperature on porous surface due to the character of phosphoric acid, which is highly polar. As M. Yako et al. Studied on different concentration of phosphoric acid, it is found that the BET surface area and total volume increase as increasing concentration of acid. Therefore, solution concentration is primary factor of activation process. In addition, the interaction of phosphoric acid and organic material lead to formation of phosphate and polyphosphate groups that cross-link polymer fragments, which introduce to the dilation process that produce a vacant porous structure after acid elimination, and some of the polyphosphates still remain on the surface of carbon after washing step. According to Low et al., surface area of phosphoric acid activated Huss sample decreased when it reached maximum value at impregnation ratio of 2, showing that its sensitivity towards impregnation ratio. Phosphate and polyphosphate incorporate in carbon matrix through COP bonds. This signifies that the phosphorus compound blocks some part of activated carbon pores, which they are not easily removed by washing. Therefore, too much of phosphoric acid added will lead to decrease in surface area. From S. Mapung's et al. Studies, the same imaging results indicate the activated carbon sample exhibit high contribution of micropore structure. The change of pore structure, where amorphous carbon being removed from the network, was caused by the reactions of phosphoric acid and the carbon. This is due to the breakage of polymeric chains and the reaction forming phosphate and polyphosphate bridge, which thermally unstable at temperature above than 500 degrees Celsius, and then it will develop micropores. Thus, the porosity activated carbon form as a result of withdrawal of the phosphoric acid and volatilization of P compound, which expand carbonaceous material structure. Table above shows the comparison of textural and functional characteristics of activated carbon derived from waste biomass and activation with phosphoric acid. Base or alkali chemical substance can be divided into three stages. The first one is strong base, middle base, and weak base. Potassium hydroxide is the most effective alkali salt activating agent, as it can produce high surface area with high porosity and enhance formation of hydroxyl functional group on carbon surface. Unfortunately, according to TSV, although potassium hydroxide able to produce high development of porosity and surface area, the yield of activated carbon produced is typically low compared to phosphoric acid and zinc chloride. This is due to the increment of carbon loss during pores development, which resulted to the intercalation potassium. According to Imistar et al., pore size can be classified into three groups, which are micropores, mesopores, and macropores. There is meso-micropore axis in all activated carbon. Potassium hydroxide activation can be performed in three stages. The first one is the products from the carbon gasification, which is water and carbon dioxide, which initiate the pore development. And then the second one is the production of potassium oxide and potassium carbonate when temperature reach 700 degrees Celsius, which introduce carbon skeleton to develop pore framework by redox reaction. The third stage is production of potassium metal at temperature of 800 degrees Celsius, which diffuse and incorporate into internal pores of carbon. As a result, development of new porosity and expand the existing pores. A key factor here is the internal surface of carbon, resulting hollow structure with high ratio micropore and mesopores. Furthermore, activation with sodium hydroxide also preferred as it is less toxicity compared to potassium hydroxide. It is able to produce a well-developed porosity and less corrosive. And table above shows the study of activated carbon by using activation of potassium hydroxide and sodium hydroxide. Activation using neutral or salt activating agent have been used as an activating agent. Oxidation states of this positive ion react with carbon atom by reduction mechanism leaving behind pore channels. Nevertheless, there is formation of carbon bonded with various morphologies and sizes that could fill the space in carbon matrix, which can be eliminated by acid washing. Among those dehydrating chemicals, zinc chloride found to be most efficient. Donald et al. Explained in his study where zinc chloride found to be efficient in developing micropore structure, while phosphoric acid has effective role in developing mesopores. Different performance of both dehydrating materials is due to the different activation mechanism. Phosphoric acid proposes crosslink formation in form of phosphate ester, which result in reduction of pore development, while zinc chloride resulting inter and intra voids due to swelling effect via lateral bonds breakage in cellulose molecules. Thus, zinc chloride, creating interspace in carbon matrix, leads to more micropores development. Ferric chloride also can be used as an activating agent as it has low toxicity which poses less pollution towards environment compared to zinc chloride and phosphoric acid. Oliveira et al. Stated that ferric chloride show better defined pores. This is due to the smaller ionic radius of ferric ion, thus producing smaller pores. However, as compared to zinc chloride, specific surface area of ferric chloride activated carbon is the lowest. Numerous researchers have attempted to search and design various alternative effluent treatment technologies for removal of dyes. However, all these technologies treatment have their own limitations, which are highly cost to conduct and accumulation of toxic sludge generates further disposal problem. Therefore, absorption of activated carbon is the most preferable method as it can encounter dye wastewater problem. The key factors influence dye absorption are specific surface area of absorbent, good internal porosity, high thermal stability, activation temperature, pH value, and time in contact. So, in order to understand absorption properties, absorption kinetic study and isotherm models has been used, which is by using Freundlich model and Langmuir isotherm model. Al-Chari et al. Studied on absorption wet dye. From his study, the equilibrium isotherm data followed Freundlich model, while Esteden et al. Study the absorption of methylene blue shows best fitted of Langmuir model. Last but not least, for the conclusion, chemical activation found to be more economical than physical activation due to the high carbon efficiency, requires low activation temperature, short processing time, and develop more porous activated carbon structure. The selectivity of activating agent depends on precursor and adsorption application. Phosphoric acid activation found to be safer to use than zinc chloride as it has less toxicity and requires low activation temperature compared to potassium hydroxide. For alkali activation, potassium hydroxide is more preferable than sodium hydroxide as it develops greater surface area, more than 3000 meter cube per gram. As for neutral activation, zinc chloride produces high surface area activated carbon than ferric chloride. An effective activated carbon not only based on activating agent, but also precursor and optimum parameters used. For example, activating agent concentration, impregnation ratio, residence time, and activation temperature. And these are the list of preferences. That's all from me. Thank you for your time. Bye and Assalamualaikum.